Yeah, we are live.
Good evening, everyone. Today's session is on the topic Bringing Realism in Mobile Augmented Reality by our speaker Sanjana Date. Sanjana is a final year computer engineering student. She is an aspiring AR, VR, and UI UX developer. She is currently working on her final year project sponsored by Flipkart and had interned at SAP Labs last summer. She has worked on various projects exploring domains such as AR, full stack development, and Android. Apart from her technical side, she is a basketball player and represents our college in various tournaments. She is no doubt an all rounder, and there is a lot to learn from her. Now, without wasting further time, I request Sanjana to take it forward from here.
Good evening. Thank you for that lovely introduction. Good evening, everyone. My name is Sanjana, and mm, right. Is my screen visible? Okay. Good evening,
Yes,
everyone. Okay, thank you. Okay, my name is Sanjana, and today I'll be speaking on the topic bringing realism in mobile augmented reality. So, before I start with the webinar, I would like to introduce myself and why I chose this topic for today. As Sejal already mentioned, I'm a final year student. I'm currently doing my BTech project sponsored by Flipkart, and I did my third year summer internship at SAP Labs. My two main domains of interest are XR and UX. So, XR means extended reality, which is an umbrella term used to describe AR, VR, and MR. AR is augmented reality, VR is virtual reality, and MR is mixed reality. And user experience UX. It is defined as the user's perception of and response resulting from the use of or anticipated use of a product, system, or service. Now, coming to why I chose this topic for today's webinar, as some of you might be aware, the computer department of our college conducts an activity called seminar for the third year students. Uh, it carries credits and marks, and the purpose is to give students the experience of doing research on a topic of their choice, creating a report, and presenting a seminar on the same. So I worked on this report and presentation under the guidance of Mochikar sir, and I was fortunate enough to be selected in the top 15 seminars. As a result, I was asked to write a paper which was featured in the computer department CSI publication. I was always interested in these two domains, XR and UX, and I picked the electives offered by the department and college that helped me grasp some of the concepts better. So, out of these, HCI, Human Computer Interaction, was the only subject that was chosen by the majority of my batchmates because, well, yes, it is very interesting, but it was known to be very scoring as well. And as for the next three electives, from these, image processing was also in my third year, computer graphics and computer vision, which I've taken now, in my final year. So these three electives, there are hardly very few, handful of computer engineering students who have taken these electives. So what I'm trying to convey here is that go ahead and choose your electives wisely. Choose the electives that you are genuinely interested in. Don't just go ahead and take whatever all your friends are opting for. Now, apart from these subjects, which were a part of my syllabus, I also did some online courses. Augmented reality and virtual reality, these two courses are available on Coursera. And the next two, mathematics for computer games development and user experience design essentials, these two are on Udemy. Now, if you're a part of our college, then you might know that our college has a Coursera plan where you can do some courses or guided projects for free. So, do take a look at those too. So this will be the agendas for today's talk. Start with an introduction of what is XR, what are AR, MR, VR, what are the differences between those. Then we focus in on AR, and within AR, we'll go to mobile AR. Then I'll speak briefly about some technological advancements. These were um some topics that I've chosen to elaborate on during my seminar. Then we'll go on to the human computer interaction, in which I'll be speaking about two parts, the interaction part of it and user experience. Then we take a look at some popular mobile AR applications, and then we'll be concluding. So, let us begin. What is XR? Well, as I mentioned earlier, it comprises of AR, VR, and MR. So, let's go into a bit more detail into each of these technologies. Now, augmented reality can be defined as an immersive experience of a real world environment that is enhanced with computer generated perceptual information. What this means is that it combines the real world with the virtual world and offers real time interaction between them. So it creates the illusion that the virtual objects exist in the real world, and it goes beyond the static graphics that do not change with the user's perspective. AR enhances the way the users react with the physical world by overlaying information about people, places, or things on the existing information to evoke memories and pleasant experiences. Next, we have is VR, virtual reality. This is the use of computer modeling and simulation that enables a person to interact with an artificial three-dimensional visual or even other sensory environment. So for VR, a person is required to use hardware like goggles, headsets, gloves, or bodysuits. A user can tour a simulated room and experience changing viewpoints and perspectives that are convincingly related to their own head turnings and steps. They can wear data gloves that are equipped with force feedback devices that provide the sensation of touch. So the user can go around the virtual environment, pick up and manipulate the virtual objects that they see. So suppose we have a VR jungle game. Okay, a person will be standing in their own home. They will wear a headset and they can walk around, and they will actually think they're walking in an actual jungle. So they can see the trees, they can see the sky, maybe even a wild animal. They might get scared and run away, and maybe they won't get scared away. And they're wearing these special gloves, and they can even pet the animal and feel how the fur feels. And all of this while staying at home. So for VR, we require special headsets to immerse the users in the virtual reality. And these headsets come in two types. So first we have PC connected headsets, and second is standalone ones. So for PC connected headsets, as the name suggests, these have to be connected to a computer or a gaming console that will generate the high quality virtual experience. The processing power of modern computers is huge, and they can easily generate realistic and persuasive digital worlds. And VR headsets can be used along with special controllers, which the users can use to interact with the virtual environment that they are immersed in. So, PC connected headsets, the popular examples are HTC Vive, PlayStation VR, and Oculus Quest. And the second type of headsets are standalone ones. And you might have guessed that a VR headset that has to be connected to a PC might be very expensive, and not everyone can afford that. So there we have standalone headsets. Now these also come in two types. So one that requires a smartphone. So it will use the screen of the smartphone to provide the VR experience. And an example of these examples would be Samsung Gear VR, Google Daydream, and Google Cardboard. On the other hand, there is one type of headset that does not even require a smartphone. So Facebook's Oculus Go completely generates the reality technology on its own. Now, VR has become very popular since the introduction of the metaverse. So, what is the metaverse? Many people ask. Well, the concept of the metaverse is not new. In fact, the term was coined in 1992 by an author called Neil Stephenson in his novel Snow Crash. in which lifelike avatars met in 3D buildings and other virtual reality environments. So, the metaverse is a combination of multiple elements of technology, which include VR, AR, and videos, where the users live in the digital universe. So, people will be able to live there, they can work, play, connect with their friends virtually through concerts, conferences, or even by traveling around this virtual world. And the third type is mixed reality. Now, mixed reality is the merging of real and virtual worlds to produce a new environment and new visualizations, where the physical and digital objects coexist and interact in real time. So, it does not exclusively take place either in the physical world or in the virtual world. It is a combination of both AR and VR. And mixed reality also comes in two forms. So we have mixed reality that starts with the real world. In this, the virtual objects are not just overlaid on the real world, they can even interact with it. So the user remains in the real world environment and the digital content is added to it. And moreover, the user can interact with the virtual objects. So this is like an advanced form of augmented reality. And an example of this is Skype using Microsoft HoloLens. Now, the second type of mixed reality is mixed reality that starts with the virtual world. The digital environment is anchored to and replaces the real world. So, in this case, the user is fully immersed in the virtual environment while the real world gets blocked out. So this sounds kind of like virtual reality, right? Well, it does. But here the digital objects overlap with the real ones. Whereas in conventional virtual reality, the virtual environment is not connected to the real world around the user. And an example of this application is the Windows mixed reality headsets. So, to conclude this part of the presentation, augmented reality overlays virtual information, virtual objects on the real world environment. Virtual reality immerses the user in a fully artificial digital environment, and mixed reality not just overlays but anchors virtual objects to the real world. Now, let's focus on one aspect of these technologies, which is augmented reality. And let's focus on one of those, which is mobile augmented reality. So, a mobile AR application can be defined as an application that is capable of combining the virtual world with the real world, offering a real time interaction between the two, registering the real and virtual objects, and adjusting the AR camera to align the two, and lastly, running this augmented view on the mobile device. Now, here the virtual world it can be in the form of 3D models, animations, annotations, even videos. And mobile AR application also has different types. So there are three types: is phone based, wearable, and projector based. Now, a mobile AR system, like any system, has three components. There's input, processing, and output. So the input is in the form of sensors which are available on the mobile device. The processing is where it determines what information is going to be rendered on the screen of the mobile device. Now, for this information, it needs to be stored in a database. So, this database can be local on the mobile phone or it can be remote, for which we would require network connectivity. And the last component is output. It has to project the output to the screen of the mobile device along with the actual physical view. So it has to actually augment reality. So I'll explain to you how the input part of it works. So first we have the camera. Now majority of our smartphones have a camera, and I'm guessing anyone what's sitting here has used a camera before. But did you know that this camera has two parts? So there is a physical camera which is going to capture images of the real physical world, and additionally there is a virtual camera which is implemented over this physical one. So the AR camera uses the virtual camera for tracking objects. Next, we have a gyroscope. A gyroscope is a device used for measuring or maintaining the orientation and angular velocity. Now, this is used by the system to determine the orientation of the AR camera. Suppose I have a virtual cube in front of me. If I move around this cube while holding my phone in my hand, I should be able to see a complete 360-degree view of the cube. Okay, I should not see the same square on my screen the entire time. And last year we have the accelerometer. So accelerometer is an electromechanical device which measures the acceleration forces such as gravity. So it can measure the gravitational pull of the device. And the computation will be used for augmenting the virtual images so that they look realistic. So these three components, camera, accelerometer and gyroscope, these are used to implement motion tracking. Now we have another sensor here, which is the magnetometer. The magnetometer is a digital compass that measures the orientation with respect to the Earth. And finally, the last sensor we have here is the GPS, Global Positioning System. So these two, GPS and magnetometer, are used to track the location. Now next, I'll be speaking about two very important concepts that help to make mobile AR realistic. So in AR, occlusion is essential for making experiences immersive. The virtual objects should be displayed only when there is no physical object between them and the camera with respect to line of sight of the user. So the AR system needs to know which all physical and virtual objects are present in the scene. It should know the user's perception, what angle they will be looking at the scene at, and they should know which objects will be occluded and by what extent. Now, take for example this example to the left here. We have this is the of an image of a virtual museum. Now we have a virtual statue over here that is going to be part of this. Now on its own, if you look at the statue, it looks quite realistic. At least I think so, because we have these various lights around it, and you can see that where the light comes from, there is a shadow in the opposite direction. So on its own, it looks pretty great. But look how it is going directly over this person, and that makes it look unrealistic and it breaks the immersion. So immersion is the illusion that the user thinks the augmented image they are seeing is real. So here this does not look realistic, hence the immersion is broken. And now let's take a look at the example to the right. Here we have an extremely unrealistic looking cartoon, Pikachu. Now it is very obvious that he is not real, all of us know this. But just look at the way half of his body is hidden behind a door. Okay, the occlusion in this image is quite accurate. So, even by having a non realistic cartoon image, it is possible to make a realistic AR scene. So, in fact, in many AR application nowadays, the developers and designers they prefer to use cartoons and non-realistic objects. Okay, that obviously don't look real, and they prefer to have proper occlusion done for that than using real looking objects with poor quality. Because the second a user sees imperfection in the scene, they will no longer be immersed. And the purpose of all these technologies and XR, AR, VR, MR is to immerse the viewer. Now, as I mentioned, so to implement occlusion, the AR system needs to have information about the depth of a scene. Okay, it needs to analyze the captured image. It has to analyze the position orientation of an object in 3D space. Now, when we talk about the 3D space, the it has to have an X, Y, and Z axis. So, pose is a term used in augmented reality that describes both the position as well as the orientation. Now, an AR scene is going to have three dimensions. Hence, we can have rotation about three different axes. So, for that, we have terms called yaw, pitch, and roll. So, yaw is around the z axis, pitch is around the x-axis, and roll is around the y-axis. Now, as part of my seminar report, I did research on various technologies and found these three most interesting to elaborate on. I won't go into depth now because they are quite technical and they require some understanding of image processing and computer vision. I mean, I myself had to study these concepts before understanding the research papers. The first is about learning optimized local difference binaries. Next is space sharing using markerless AR, and last is ARCore. Now, I'll briefly again explain to you how an AR system works. As I mentioned earlier, every system has an input, a processing unit, and an output unit. So, in the input, it will use the various mobile sensors to detect objects in the scene. This is called detection. For processing, it has to store the information in a database. So, this process is called registration. And last, it has to overlay the virtual information over the physical view. And this is called augmentation. So just imagine how computationally intensive this process must be. So we have a term called scalability. Scalability is the measure of a system's ability to increase or decrease in performance and cost in response to changing demands. Now, suppose I have an application that I want to use so that can help people to get over their stage fright, to get over their fear of public speaking. So I'll decide that I want to first practice public speaking. Suppose I want to practice my talk for today and I have stage fright. So I've decided that I'll first practice by myself and then I want to practice in front of one person. But I don't want to talk in front of real people because I'm still nervous. So I'll create an application from which I can hold my phone up. I will see a virtual chair in front of me and my application will place a virtual person on top of that chair. Okay, and I'll practice like this. And okay, now I'm getting used to it. So let's scale it up a bit. I think that I can talk in front of two people. Now we have two chairs and two people. I've been doing this for 2 hours, and I think that I can practice with more people now. So suppose I take 10 people. So I'll have 10 chairs and 10 virtual people in front of me. And I practice this. I think I'm getting better. So now let's have a test run with 100 people. Okay. So I'll have 100 virtual chairs on which there are 100 virtual people sitting in front of me. And I'm a bit nervous, but I managed to get through it. So now I really want to push myself and I want to practice in front of 1000 people to see if it really works. So I'm my augmented reality application has to have 1000 virtual chairs and 1000 virtual people sitting on those, a packed room. And suppose it's like a seminar hall and everyone will be watching this. So just imagine, just through this example, our example first had one person, one chair, and now it has 1000. So our application has become 1000 times more complex than it was initially. So most MAR systems, they're not scalable either because of the descriptor, which is the algorithm that is used to detect the objects, or they're not scalable because of the size of the database. So local difference binary, it is very efficient, robust, and distinctive. Well, how it works is that it takes input in the form of an image and it will output the feature vectors. This is a concept from computer vision, some of you might know. Next, it will process these using a modified adaptive booster algorithm and find matches in a large database using very efficient techniques. So, using this proposed method was not yet implemented in the research paper. The MAR systems can become scalable and provide a rich user experience. The next technology, again, this was a proposed technology, not yet implemented, was space sharing using markerless AR. Now, most augmented reality applications are meant for single users. There are some that are meant for multi-user user, but these rely on markers. So, in marker-based AR, there are special pointers or markers that are placed in the scene. You have to hold your device up and scan that marker, and that will trigger a virtual object to appear on the device. But now here this technology that was proposed by these researchers, it did not use markers. It was markerless AR and it relied on depth cameras. Now I'll explain to you the difference between a depth camera and a normal camera. So the normal cameras that our phone uses, if we click a photo, we get a 2D image. It has two dimensions, X and Y. So, when you take an image of an object in a real world, it has three dimensions, X, Y, and Z. But our image has two dimensions. So, we're losing one of those, which is along the Z axis, that is depth. This is how a normal camera works. So, this system is using a depth camera in which that third dimension of depth gets preserved. And then it uses a special algorithm called ICP to realize the AR scene. Now, the last technology that I wanted to elaborate on in my report was ARCore. So, ARCore is a platform built by Google for building AR experiences. For the way it works is that first it has to track the position of the device, and next it has to understand the environment around this device by making API calls. So the features of this ARCore are that it can provide real-time 3D interactions. It can do motion tracking. It can do light estimation to make objects look realistic. If you remember the example shown before of the virtual museum, the statue had very proper lighting where there was a light coming from one direction and shadows exactly opposite to it. So those make the virtual objects look realistic. And Google AR Core allows multiple users to share an AR space using a concept called cloud anchors. Now, coming to the human computer interaction aspect of it, I'll be speaking about two concepts, interaction and user experience. Now, unlike traditional augmented reality, mobile augmented reality has certain limitations. First is that we have to hold our phone with one hand and use our other hand to interact or manipulate the virtual objects. So here we already have one problem of accessibility. Now, second issue is that we have no keyboard, no other input device for this. Everything has to be done through that phone screen, and that size of the screen is very small. Okay, we are going to create a virtual world, and we are going to use a small screen as a window to have a look at it. And last is the phone battery. All of you might know that if you play a game for many hours, it is going to drain the battery of your phone very quickly. Now imagine playing an augmented reality game on your phone and just how fast that will drain your battery. Now this is going to give an unpleasant experience to the users. They won't feel like using it. It will degrade the performance and this will lower the overall user experience. Now, these are the precision target selection techniques. These again, I won't be elaborating on these right now. If you want me to later on, you can do it later. Now, interaction in augmented reality is very complex because we have the an AR tracker in our AR camera, and if you remember, there are three components to an AR system: input, processing, and output. Now, in mobile AR, this AR tracker has to work as both input and output. It has to detect the objects in the scene and it has to overlay the virtual information on top of the view that we are seeing. So there are three types of interactions in MAR. The first type is touch based. This is very easy for humans. You just have to tap your fingertip on the screen. It's very natural and intuitive, but there are two major issues. So first of all, it is very easy to drag an object left to right, top to bottom, but it is difficult to move it front and back. This is because, as I mentioned before, the dimension of depth gets lost when it gets mapped from 3D to 2D. And the second issue is fat fingering. If you have a very small object on the screen, or you have a congested scene with a lot of overlapping objects, it will be difficult to isolate one object and move it. The second type of interaction is device based. Many of you might have played mobile games. where you have to tilt your phone to move the object side to side. And the third type is gesture based. Now, gesture based is very natural for human beings. In fact, even right now, my camera might be off, but I am moving my hands naturally as I speak. But this is going to be very complex for our AR system. Now, our AR system, it has to already do such a complex process. It has to detect the objects, it has to store it in the database, it has to augment these other images, and on top of that, it also has to track our hand movements and understand what gestures we're trying to make. Now, coming to user experience. User experience is defined as the user's perception of and response resulting from the use of or anticipated use of a product, system, or service. But all the tech giants, or in fact even smaller companies, they have a dedicated UX team that consists of researchers, analysts, and designers whose job it is to do research on how the interface, how the look and feel of the application should be. And the purpose of the app should be fulfilled in an efficient manner. But you also want users to continue using your app, right? It shouldn't be that your app was so good that I don't need to use it anymore. Then you're going to lose business. Now, take for example an IKEA store. Now, did you know that the physical layout of their stores is such that no one can just walk in and out in 5 minutes? They make sure that if a customer walks in, they will spend at least 1 hour there. And to exit the store, you have to walk past all of their tempting and beautiful furniture. Now, this is very carefully planned so that the store gets maximum sales and also so that the customer can leave the store feeling happy. This benefit has to be twofold. No, UX is not the same as UI. UI stands for user interface and it is just one subset of UX. UI deals with just looks and aesthetics, whereas UX has to deal with the entire process and the experience that the user will go through for using your application. Now, there's something called a user experience process, and this process is very similar to a software development lifecycle. So, this is an iterative process which starts with research, goes on to development, and ends with testing. And this will keep repeating until your goals are met. Now, coming to designing for mobile AR applications. So, AR applications are very different from traditional applications, and so the challenges are also very different. The biggest challenges are environment location and graphics. So, keeping these in mind, there are some design guidelines for creating applications in mobile AI. So, first is that 3D interactions are different from 2D interactions. It is very easy to move an object left to right, top to bottom, but it is very difficult to move it front or back along the depth. Also, the user interface of our application should have very minimal options. Okay, the focus of our application is the virtual content that we'll be displaying over it, not the hundreds of controls that we've designed where the user can use. Also, it is considered a good practice that the visual content should be placed either directly in front of the user or slightly above their line of sight because people tend to experience motion sickness sometimes. If they have to move around and focus on multiple virtual content, it can get quite tiring. The next we have mental models. So, what mental model is that keep the application, the interaction, and the content as intuitive and natural as possible. The users need to feel comfortable, otherwise, they will not accept this application. Now, this might sound hypocritical because, well, we have a completely new technology. We want to create a novel and exciting experience for the users. So, how can we say you have to keep it as natural as possible? Well, the icons that we have to have you realized that a delete icon that we have on our applications, it looks like a trash can. It's because we can relate to it. If we want to progress through a mobile application, we go from left to right. Because that is how the flow works in all the other systems too. And if you want to go back, it will be reversed. So the user should be able to relate to the concepts in our application with some real world concepts so that they will accept our application. Now coming to environmental concerns. Now, there are many failed videos that come online. Okay, a person is wearing a VR headset, and suppose they're doing virtual reality boxing, and they're moving around the room, boxing some virtual creature in front of them, and at the same time, and unfortunately, a person walks in front of them, and this person wearing the VR headset boxes them very hard, and this person actually gets hurt. Okay, and while these videos are fun to watch, they bring out a genuine concern about safety. Safety is a concern, and even apart from safety, there are some environmental concerns when it comes to implementation. So in augmented reality, it is known that it is difficult to track a smooth surface or a surface that has poor lighting. So, if you have a textured, rough wall in a well lit environment, that will always be easier for the application to track. And last, we have visual affordances. Now, visual affordances are visual clues that are made in the design itself. So, let's take an example. Look at this example here. We have a bear that is kept inside this cube. So, if a user sees this, they'll have some understanding that this bear is confined to the space inside the cube. So, if I'm using the application, I can't directly access the bear. I can't touch them directly. So, I have to do something to get through this barrier of this cube. Now, let's take a look at some examples of popular AR applications. Now, I know that augmented reality games are very popular, and when we say augmented reality or mobile augmented reality, the first thought that comes to our mind is Pokemon Go. But today I have not kept that in the examples here because AR has many applications apart from games also. It has applications in retail, advertising, tourism, navigation, entertainment, education, and construction, and many more domains. So, the first application for today, as examples, is the IKEA Place app. This app allows the user to see how the furniture will look in their homes and even make better recommendations. So if you want to buy a couch but you're not sure what color to get or how big a couch to get, this application is the perfect solution for you. So next we have Google Maps. So the AI feature in this app, it will guide you, assist you on your journey. It will make efficient recommendations and even give you a scenic route. And the third example is Flipkart Camera. So Flipkart recently acquired a company called Scapit, which works in XR. And then they released this feature called Flipkart Camera. So the way it works is that you first need to scan a QR code using either Google Lens or another third party app. And then once that page opens, you get an option called View in your room, and once you click on that, you will see a camera open, and then all you have to do is point your rear camera to the floor for some time, and then it will enable the AR mode, and within seconds you will see a life size replica of that item in your home. Now, this is a working example of how marker based AR works. It places a marker at that scene, and once you scan it, it triggers a life size replica of AR replica of that item. And you can even move these, you can interact with them, you can move the orientation around as per your preference to understand how this item will look inside your home. Now, here are some very popular AR development SDKs. There are many more, but I have only listed out these six for now. So, the first two, Unity and Unreal, these are actually game engines. The next two are mobile AR platforms. ARCore is made by Google. I hope you remember this. I mentioned it a few minutes ago. So this is meant for Android devices. And ARKit is an equivalent of ARCore. This is made by Apple and it is supported by iPhones. And last here we have Spark AR Studio and Snap AR. So these are SDKs made by social media companies. Spark AR Studio is made by Facebook or Meta. and this is used to design, create, and publish the Facebook and Instagram filters. And Snap AR, as the name suggests, it does the same, but for Snapchat lenses and filters. So, out of these, I have used Unity and Spark AR before. Now, Unity is a cross platform game engine developed by Unity Technologies. It gives users the ability to create games and experiences in both 2D and 3D. And it has many features like retargetable animations, full control of animation weights at runtime, and very sophisticated state machine hierarchies and transitions. So we can actually apply the laws of physics in a game and control these game objects individually with the help of C sharp scripts. And even though it is a powerful, it is a game engine, it is very powerful and it can support AR and VR. And you can build real time 3D projects for many industries like animation, automotive, architecture, etc. So, to create mobile AR applications, you can create that app in Unity and export it to your mobile device. Now, today I won't be giving a demo of an AR app. Unfortunately, I wasn't able to connect it to my phone, but I can show you how it works. So this is the official Unity website. Here they have many tutorials that you can follow to learn how Unity works. And this is a tutorial for plane detection using AR Foundation, which is the library that is used. So this is how Unity looks. This is the scene that we have, and these are the various assets that you add to the screen, and you can configure them here. And as I mentioned, there are C sharp scripts that you can use to control these devices. And next, there is Spark. So, Spark is created by Facebook or Meta, and moment, yes, it's an augmented reality platform for Mac and Windows that allows you to create AR filters for your mobile cameras. So it works like Photoshop but for augmented reality. So in 2017, Facebook decided to launch its own software for brands and designers to create customized AR effects. AR on Instagram has enormous potential as a marketing tool, but it wasn't being used to its full extent. So because of this, businesses had a lot to gain from finding creative ways to build and share their own branded AR experiences on Instagram stories. Imagine a makeup company can simply just create their own makeup filter and people can use that and see if they like it and they can buy it. This will boost their sales majorly. So this is the Spark AR website which has many tutorials and projects that you can follow. And here is an example project of creating a face tracking effect which can place these filters on your face and it tracks when you move your face. So if you move from left to right, the filter will also move. So they have very nice videos and step by step instructions, very concise that you can follow, and this is how the Spark SDK looks. So this is the same. This is one feature that I liked a lot. If you've not connected your device, it will show you how the filter, how the application will look when you're applying all of these. Now, this is the hierarchy of all the assets over here, and we've added various textures. And if you want to test how this filter will look, we have two options here. You can either send it to your Instagram or Facebook accounts. Then you can directly open the app, Instagram account, your app from your phone, and see how this filter will look on your phone itself. Otherwise, it has an app called Spark AR Player. You can download this from the Play Store and you can send it to your device. So right now my phone is connected and you can just send it and you can open that filter from that app and use it. So to conclude, mobile phones are abundant and the market for augmented reality has grown immensely. The global augmented reality market is projected to grow from its current value, it already has a value of $6 billion, and it is projected to grow to almost $100 billion just in the next few years. And AR content creation requires special software and hardware due to the extent of the computations that are required for these real time processing for large volumes of data. With the progress that is made in this field in just a short period, it is safe to say that the technology is yet to reach its peak, from being just a fad to a norm for users. These were the references that I had used for creating my webinar and the content for these slides. So these are the research papers, and this is the official ARCore website. If you want to learn more about ARCore or any of these, you can just definitely take a look. So yes, that's it from my end for now. Thank you so much.
Yeah, so we'll take the questions now. So the first question we have is, as you said in the beginning that your seminar was ranked in the top 3, could you explain what approach did you follow while you made your seminar?
Okay, right. So my seminar came in the top 15. So what the department does is they don't actually tell you your ranking as such. They just say that these are the top 15, and if your name is well, congratulations, you've done a great job. So first things is, of course, I think very important is that the topic that you choose. It shouldn't be just a common seminar topic that you look up online. Those are even the teachers get bored of looking at the same topics over and over. It should be something exciting, not just for the teachers to see when you're presenting it to them, but also for you, because you will have fun learning more about this topic. And the other thing is, ta- take advice from your guide. Okay, as I mentioned, my guide was Muchikar sir, and he helped me a lot, even starting with narrowing down my topic. So initially, I had just given topics of UX and AR, and so I was given advice by the teachers that you need to narrow it down. So then I worked with my mentor, and he helped a lot in narrowing down which topics and which to elaborate on, which you can sort of just skim over. Right. So that is my advice. First is most important is the topic that you choose, and second is take help from your mentors.
The next question is, what are the potential job opportunities in the field?
Yes. So the AR industry is booming, and there are not just big companies that are hiring. There are also many startups. So I would suggest if you use LinkedIn, just go ahead to the search bar and search for people who are working in this industry. Many of them, so the tech stack that is used in this is very similar to what is used for games development. So many of them start with game development and move on to XR, but the this field is growing a lot, and there are a lot of jobs out there. So if you are interested, you can try taking one.
Yeah. Next question is, how did you learn these concepts and what skill set does one need to go forward in this domain?
Okay, so how did I learn the concepts? So the first thing for me started with doing online courses. I did some courses on Coursera. One was Introduction to Augmented Reality and ARCore. This is great. It is a beginner course. It explains everything that you would need to know, but it doesn't get into enough depth that you will get the implementation. And this course is actually made by Google itself, so it is very interesting and very useful. Take a look at that. And the second course that I have done was Introduction to Virtual Reality. Now I have not implemented VR myself, so I was still keen to learn how it works. So I did this course, and the concepts are overlapping because these technologies, the tech stack does overlap, and it was also very interesting. So when I the first thing that I found out was that uh, I had access to Unity, because all of us have through our college email IDs, you will have access to a GitHub student account. and through this student account you get lots of freebies, and one of them was a Unity student account. So I signed up for a Unity account and I downloaded the application, and that's it. I opened the website and I started doing the courses. So for this, the language that they use is C sharp, which I had never used before. So I did some courses on their website for learning C sharp. So they have many courses for creating simple 2D games or 3D games. And so once you get used to this language, you can start doing the courses for the augmented reality applications. Now this is again just for Unity. There are so many more SDKs, so it is completely up to you. Just search once online, see what suits you, and go ahead with it.
Yeah. The next question is, what are the prerequisites required for getting started with AR VR development?
Okay, I think I answered that in the previous question. You
Yeah.
can just you don't even. So I did a course, okay, and that was free because you might know that our college has a Coursera plan in which you can do some free courses. So take a look at that if you don't want to pay for the course. Otherwise, you can just search online. There's a lot of content, a lot of articles, and YouTube videos also of step-by-step tutorials. So just start reading articles, start reading online. That's all you need to know.
Next, we have how AR is currently being applied in the industry.
In the industry. Okay, so in the examples that I showed you, those were from point of view of retail. So where IKEA and Flipkart, what they do is whatever furniture or items that they are selling, you can just sit in your house and see how that item will look in front of you, in front of your own eyes, how it will look in your homes. So this is in terms of retail and retail. So and then in terms of marketing, as an example that I showed you, if you use these Snapchat lenses or Instagram filters, if you want, you can simply just make a filter and publish it to their site, and anybody in the world can see that filter and use it, and that is direct marketing. Apart from this, it is used in navigation. As I showed you, Google Maps has an AR feature that can help you navigate your way. It is used in education. Imagine this scenario right now where kids had to go through online learning, and it was not easy because they could kids rely on seeing things in front of their eyes and visualizing it. So if a child had to learn about wild animals, they have to see a lion, and obviously they can't go to the zoo, right? If they can't go to the zoo, imagine if you have an application in which you can just hold your phone up and see in front of you how a lion would look. Now, certainly that the child is going to be able to remember that experience much better than just reading up some article about it.
Yeah. Next question is, what is the future scope in AR VR?
Well, right now, every domain, every tech company is trying to get into AR VR, and that is mostly because of the metaverse. When Meta announced that they're going to have this metaverse, every company, okay, starting with tech companies, Microsoft decided that they will do something on their own, and even Nike said that they are going to have their own virtual world in this metaverse where people can work out and do this. So every domain you get into, from sports to technology to education to retail, marketing, branding, there's scope for this in every domain.
Next, we have it was very interesting what you explained. I wanted to ask, how do I get started with this and move forward to seek career opportunities?
Okay, so most important is that, okay, first of all, you can do courses. You can look up YouTube videos, that is also free. Start doing projects, and then you can start looking for jobs. So first thing is you need to try this on your own. Do start doing projects. This is for true for any field, not just AR VR. Any if you want to get into any other field, also you have to show some projects on your resume.
Next, what is your Flipkart project on?
No. So my Flipkart project is not an AR/VR project. It is a full stack project that we're using Mon Stack for using React JS.
Next, just had a general question too. How did you get your final year project sponsored by Flipkart?
That's an interesting question. Okay, so my teammates had done. Two of my teammates had taken part in their mentorship program, and that is how they got in touch with the HR there, and they approached them, and that is how we got the intern project sponsorship.
Next question. As an undergraduate, can we get a job in the field, or doing a master's is necessary to get a job role in the industry in this field?
Yes, so I myself was faced with this question. A lot of people don't do a master's. Some of them, it is possible to get a job without a master's degree. There's no doubt about that. So I myself was have not got a job in this field yet, and but I do want to pursue a master's. So don't. It is completely up to you. I myself am doing research on this. So when I find out, I can let you know. But you should also start asking some people around.
Yeah, I guess that's it for the questions.
Okay. Thank you so much for letting me being part of this speaker series. When I was first approached, I got very nervous. I thought, oh my god, why are they asking me? I'm like a. So I've seen the talks that you guys have hosted before, so it was a great honor for me.
Yeah, thank you so much. It was an amazing talk. Thank you
Thank you.
everyone for joining the session.